it's kind of ironic because as developers, we know how easy it is to compile code these days. So I'm sure like this is a Node conference, so there's a lot of Node developers here. So whether you're compiling and bundling your application into like minified JavaScript files, or maybe you npm install, you pull all your dependencies, maybe you have 100 files and you package them up. The biggest challenge these days is how do we deploy and get these files to a server? So it's all about copying files to a server, and we have all this tooling. So in this day and age, we have Docker Swarm, we have Kubernetes, we have Heroku, we have all these kind of tooling just to get files onto a server. And we all work together in this group therapy that we call DevOps to deal with the pain of copying files to a server. So the motivation behind my talk is not just to copy code to a server like we're going to do today, but to showcase some of these traditional problems that we face and how we can solve these traditional problems with modern tooling like Docker and Kubernetes. So the idea is how can developers leverage this technology on their local laptops and make your environment, so your Node.js application, behave like for like between your laptop and production. So that is the whole challenge for this talk, and I hope you guys can get some value out of what I'm going to show today. So a little bit more about me. So you're probably wondering, who's this guy? My name is Marcel, and I am a solution architect. I work on distributed system platforms, microservices, performance engineering, containers, Kubernetes, and Linux. I love Linux. I like to go into the lowest possible details when it comes to running applications. I like to know what Node.js is doing under the hood and what is the Linux kernel doing under the hood of that, and analyze performance and things like that. I find these kind of things fascinating. But then at the same time, I deal with a lot of people. So people from different cultures all over the world. And although everyone is very different, we all stumble upon the same problems when it comes to building and running applications in a cloud native environment like Kubernetes. I also am into health and fitness. So at the moment, I am working out in my garage, given the time of the year we're in and the problems. But then I also run a YouTube channel. And that being said, I have my website, marceldempers.dev, which is focused on building a learning platform. Because I deal with so many different people, I see a lot of the same problems that we stumble upon. When we're writing code, we want to get it to a server. And we focus on how do we get the code to be portable. So if it runs on my laptop and a new developer comes along, how do I make it run on that person's laptop as well? Maybe that person is running Mac OS or Windows or Linux. How can we make sure that we can get development teams up and running, agile and extremely, focused on productivity within like seconds, rather than taking a week to get an application to run? So my whole focus is about knowledge sharing. And what I've done is taken all of these problems that I've found and build up a little solution like a Docker development guide, which is focused on pure container-based development. So instead of installing like 10 different versions of Node.js on your machine, you run everything in a container. So for those who know me, on my work machine, I run Linux, and I run absolutely everything in Docker. I run Visual Studio Code, I run Google Chrome, Firefox, all of this stuff in Docker, and it's all open source. And that's the beauty about containers, is you can run everything into a container. So that's the Docker development guide. And then I've taken this one step further and done like a Kubernetes learning guide as well. And the aim with that is, how do we make it so that even like BAs, QAs, testers, people who don't necessarily write code can also learn what Kubernetes is. And people that also struggle with the command line, I find a lot of guides and tutorials don't focus on people that are afraid to use the command line. So these are the kind of problems that I see, and that's what I try to solve in these types of videos. And I use this because as a solution architect, you have to constantly learn new things. So as part of learning all of this stuff, the best way to learn is by doing. And if you're doing it in front of a camera, it's even better, because then you can take all of these ideas, condense it into a video, and video is very powerful. And YouTube is free. So it's free for me to upload, and it's free for you guys to consume it. So doing that, I spoke about deploying applications. So today I'm going to show you a Node.js application, and we're going to build it into a container image, and we're going to ship it to Kubernetes. And I've made this video, and this is kind of like the motivation behind this talk and behind everything I do, is that this video is called Software is Hard, so keep it simple. And in this video, we talk about fundamentally what pain points there are with software engineering these days, whether it's writing code, the packaging, the build systems, the pushing that code up to a server, whether it's the different cloud providers, you've got proxies, load balancers, service meshes, all this types of monitoring that's available these days, and how do we deal with software. So now I spoke about copying code to a server, and that we've been involved in this process for about 30 or 40 years now, since IT has become a thing. And now before we can really simplify all of this, we have to take a look at what's involved in deploying and building software. So as developers, we like to write code. So that's the first thing we start doing. We get our favorite text editor, we start writing code, and we're fairly happy doing this. This is our happy place. Everyone likes writing code and learning about Node.js and what it can do. But then the next step is also writing test, because we have a Jira ticket, and the Jira ticket says, no, we need to write some tests. And maybe we're not smiling with like teeth showing, and we're not that excited, but we know we have to write some tests, because tests are important, and the Jira ticket is not going to pass if there's no test. And because the code is always bundled with testing in mind, we know the quality is going to be improved, so let's write some tests. But then comes the building of the server, and this is where things start to go gray, when we need to compile code or build the code. And when we take a look at like building code, this is where we produce this thing that we want to copy to a server. So whether we run some kind of thing where we installed with NPM to produce some bundles, or whether we writing Golang or C# or whatever language it is you're writing, we're going to be basically making a file that we want to move to a server. And that's the hard part. Now, that's mainly because we have all these dependencies. And if you think building an application is hard, you should try running an application, and try run it everywhere, because you have Windows users, you have Linux users, you have Mac OS, you have all these different operating systems, you have different cloud providers. How do we get this stuff to run across all cloud providers? And this is where, the famous quote comes that it works on my laptop. So I have every single version of Node.js installed, so it's happily going to work on my laptop. And when a new developer comes, he has to read the Excel spreadsheet of what to install to try and make this application work on his machine. So application portability is a key thing in cloud native type environments. So that's a gray area. And then we look at what it takes to deploy. Now, if you think building is hard, are there any sysadmins in the chat? So if you're a sysadmin, type 1 in the chat. And this is where no one has a clue what's going on. This is like, the code finds its way, and it goes to a cloud, and it sits behind a DNS, and it just happily works. And so somehow the code that we wrote made its way into a server. So now I want to show you guys, if you've never seen an application before, if you haven't seen a Node application before, I don't know what you're doing here, but I've decided to create a very, very basic Node.js application. So here we have server.js. So I've taken the most favorite Hello World application known to the Node community. And what we do is we're running an Express server. We're hosting it on port 5000. And we just make an Express object here, and we define our route, and we tell our app to listen. And we write something to the console, because we have to know that it's up and running, right? So that's a very basic Hello World application. So what we normally do as Node.js developers is we say npm install, and that's going to go ahead and install the internet into my computer. So now that we have the internet, we can say node, we can say node, and we say dot. So we can run our application. So now it's running on port 5000. So let me go ahead and pull that up. And there we go. So this is the problem with software development, is a lot of the times as a developer, we think that this is where everything ends. This is what it takes to get the application. Now I'm done, I can carry on with my life, and this is pretty much where software development kind of stops. And that is one of the biggest problems when it comes to running applications and running software. But the truth is, it's not that simple. So let me go out of that, and let's get back to the slides. So it's not that simple, because software is hard. So just when we talk about running application, we also have to talk about, now, how do we get that application onto a server? How do we get it into the cloud? And because it's not always focused on just writing the code and then, okay, now it's running on my machine. So now we also have to take a look at what does it take to run software and run it reliably. So how many of you actually know how much CPU and how much memory your application is using in production? So that's, a lot of people don't actually know this, and they don't know what the resource utilization of their application is. And also, when you're running your Node application, do you have any kind of feedback loop? So if you don't know how much it's using, do you have some systems in place that gives you some feedback to say your application is using like most of the CPU on a server, or you're running out of disk space, or your application is throwing errors, and maybe you're getting 500 server errors, HTTP errors. So how can you improve performance of your application and schedule it reliably if you don't really know how your application is performing in production? We also talk about scalability. Now we live in 2020, and I know there are a lot of applications out there that still cannot scale. So we talk about like load balancing. If you want to scale your application because there's demand, now instead of running one instance, you want to run 2 or 3, or maybe you want to scale up to 10 or 20 or 100 servers. You're going to need a load balancer behind your Node application. So now we're talking about load balancing and proxies and how to operate these things. So it's not that simple as just deploying it to a server. And if you have things like session state, I've seen applications where they're running one instance and the user is logged in, and all of a sudden when you scale to 2 servers, now all of a sudden the user gets logged out because they get load balanced to separate servers. And then we talk about the networking side. So behind the scene, there's always like, how does your application find the database? How does it make a call to the database? If you're getting networking errors and socket errors, what's happening behind the scenes? We talk about service discovery, how applications find each other, and different systems that we have to maintain and build just to get service discovery working. And then again, hats off to my sysadmins, but restarting. So if that Express web server that is running our applications becomes unresponsive, who is going to restart that application? And who's going to take the phone call at night when that application is down and customers are, confronting errors on the website? So we talk about restarting of the applications, but also restarting of the servers, the underlying infrastructure that becomes unresponsive. So we have all of these things that we have to deal with, and then we have to think about just to run our application. Now, if we take a look at all these things that we have to do, like I still don't understand how a lot of developers and operations people are not embracing the modern tooling that we have today that's kind of fundamentally designed to deal with these problems. So let's take a look at these steps, and let's divide them up into 3 portions. So we know that on the left-hand side, we write code and we write tests. And that's the happy path. That's the most fun that we're having as developers. And then we know building the application becomes tricky. because now you have, like, if you're writing Go, you have Go, Get, and all those types of things. If you have Python, you have pip, and you have different versions of Python, you have different versions of Node.js. You have to manage all of these dependencies. And then if you want to install Node under the hood, there's always dependencies that Node might need. So if you're bootstrapping a build server or a production server, you need to make sure that you have all the C libraries that Node.js might need in order to work. And then that ends up with every server maybe not being the same. So this is where Docker comes in. So when someone gives me their Excel spreadsheet of, like, okay, this is my Node.js application, this is everything you're going to need to install, I usually ask them to give me a Docker file. So let's take a look at what a Docker file looks like. So I'm going to pull up my terminal again. And so this is my Git repository, and over here I have a Docker file. So I like to keep the Docker file at the root of the repository. So it's the first thing you see when you come in. That means a developer or an operations person or even a sysadmin can look at that file, know exactly, okay, this person is using Node, this is how they're getting their environment up and running. So what I'm going to do is I'm just going to print out that file, and look how simple that is. So we say exactly what version of Node we're running. We say that we require Node, and we say we're going to run a very small Alpine flavor of Node. So Alpine Linux, very tiny operating system, and we say we're running version 12. And then we define a working directory. We also copy in our package.json, because this defines all our dependencies that we want to run. So now I don't have to share the knowledge to every developer in my team to say, you're going to need this installed, you need this version of Express, and when you write the next microservice, you might need a different version of Express, or whatever dependencies you need to pull. So in this, it's very self-explanatory. We can see we're running package.json that has our dependencies. We say npm install, we copy the source code, and then we start up our app. So this is pretty much everything I showed you guys earlier, but this time it's documented in a self-documented Docker file. So what I'm going to do, I'm just going to exit out of this container. And what we're going to do is we're going to say Docker build. So I want to build this, and I'm going to pass in dot, because dot is where my Docker file and source code is. It's the context. I want Docker to use the current folder I'm in to create a Docker image. And then I want to tag it, and I'm going to tag it as hello world. And the specific version is called v1. So this is now very simple for any operations person or DevOps person, engineer, developer to compile the app. Because under the hood, this could be a C application, it could be a Node, it could be Python, it doesn't really matter. All I need to know is how do I build it, which is just this straightforward Docker build command, and how to run it, which is again a Docker run command. So this kind of unifies and creates a standardization for building applications. So across the whole company, if you have distributed teams, you don't have to share that knowledge about, okay, this is the exact steps you have to follow to get microservice A up and running. You can just say, go to the GitHub repo, type Docker build, type Docker run, and you can get it up and running with relative ease. And then let's take a look at what it takes to run that container. So if I say Docker run -it, and I can tell Docker that I want to interactively run a container. I can say --rm to say remove the container when you're done. And I'm going to expose port 5000 because that's the port that our Express server is running on. And I say hello world v1. And there we go. So you can see I did not have to know anything about Node. I did not have to know how to install any dependencies. I did not have to even install Node.js on my machine. And now I can go to the browser, and let me pull that up again for us. And there we go. So now I have the same thing up and running, but this time I have it running inside of a container. So it makes it really, really portable to now push this container image to another team, and they can run it without having to have domain knowledge about that application. And what I can do as well is if I just pop up another terminal, I can say Docker PS, And this can list out all the applications that I'm currently running on my machine. Now, I don't want to go into too much detail about Docker Compose, because you can also bootstrap databases. You can bootstrap multiple microservices, so you can create a production-like environment on your laptop. But that's not what we're going to get into today. I'm just going to show you how to run and build containers. So then what we do is we say, we're just going to destroy this one because we're done. So I say docker rm-f, so remove it forcefully, and there we go. So if I say docker ps now, the container is gone. So you can see it's very straightforward, very universal. Okay, and the final thing we can also do is, if you have like a registry or somewhere that a hosted registry, or you have a Docker Hub account, what you can do as well is you can say docker build, and you can tag it with your username. Or if your company has their own Docker registry, you'll have your company name in there. And what I can do is I can just say, I'm going to push it to my, I'm going to tag this as my own registry. I'm going to say hello world v1. So now we're building it, but this time I'm tagging it with my registry name. So what that allows me to do is I can then say Docker, instead of saying Docker build, I can now push that off to my registry. So you just say Docker push and the image. And there we go. So if the demo gods and the internet allows me, I already have that version running up there. So it uses caching mechanism as well. But you can see fundamentally what I've done: built some code, I've pushed it up to a registry, I've run it locally, and I did not have to have any knowledge about Node. So let's get back to our slides. Okay, and then, so with Docker now, you can see I've got Docker build, Docker push, Docker run. So a uniform standard way of running applications. That helps now to make the application portable. So any developer can say Docker pull, they can pull that application down, and they can just say Docker run to get it up and running. And they don't have to really follow so much documentation and what dependencies to install just to get the app running. And Docker also allows us to, and this is something I do in my Docker development series, is I show developers how to build your application with Docker in mind. So you install debuggers in your app. That means you can even attach a debugger, and you can use VS Code to debug your application while your application is running in a container. So that means you're almost getting to a like-for-like situation with production, because if an app runs in a container, that container is what's going to be running in production, not your local laptop. So now we take a look at the right side, and we have like resource scheduling, we have monitoring, logging, scalability, load balancing, all of these complex stuff. Now, the whole purpose of this is not to tell developers they need to learn about all of these things, because as a developer, you shouldn't have to worry about resource scheduling, monitoring, logging, and all the complexities involved in the lower details. This is where Kubernetes comes in. So the whole point of Kubernetes is to abstract away the networking and the service discovery. Kubernetes should automatically restart your application when it becomes unresponsive. The logs should all be centralized using Kubernetes, so you can use something like Logstash, like an Elk stack, or a separate third-party application, and you can bring all your container logs together and push that out to a third-party system. And then we talk about like resource scheduling. So you should not have to worry about how much CPU do I have on this machine? Is there space for another one? And run an Excel spreadsheet to try and to marry up applications to servers. You can run a Kubernetes cluster and just have Kubernetes take care of where the application runs. So that is Kubernetes. Now, before we get into detail of Kubernetes, let's take one little step backwards quickly and talk about Docker. So from what we've seen now is that Docker becomes a standard. So it's like one way to build, push, and run applications. It describes our dependencies. So as an ops person, I don't have to go and find out who do I need to talk to figure out what is installed in this application to make it work. I can just look at the Docker file and see exactly what dependencies the developer needs. It's readable. It's also easy to follow. So it's not just developer focused and it's not operations focused. Anyone that can read a Docker file top to bottom will be able to follow it. It's very, very simple. So then it also provides a standard of building software, and then we did Docker push, so standard of getting the distributable binary or the package pushed to a registry, and then a standard of running the application. And the other thing I really like about Docker is it becomes a source of truth. So we have this thing called like GitOps, where if you haven't heard of it, it's managing your source control, your source inside of source control, and using your Git repository as a form of deployment and version control. So every time you make a change in Git, you trigger a build, you trigger your tests, and a deployment goes out. So source of truth, again, the Docker file tells us exactly what we need. And then containers are also enablers. So a lot of people, especially in the DevOps space, or if you're a developer and you want to try out the latest version of Node.js, it's really simple because you go to your Docker file, you flip out the top where you say from Node, let's say 12, and you want to jump to 14, you just change that line, you try to build it, and you go from there. So containers help us to really try out new things without having to install something on your local machine and then find out later that it's buggy and you can't get rid of it. So that's why I really like containers. It allows me to learn open source really easily. And the other beauty is you don't need anything installed on your machine or your server but Docker. So this makes servers in the cloud really manageable, whether you're running on Microsoft Azure or you're running in Google or Amazon AWS. You just need a server with Docker on it. You don't need to go and manage what's installed on that machine. So let's talk about Kubernetes for a second. So Kubernetes, what we're going to take a look at is a file. Now Kubernetes is all about desired state. So I said I don't really care how Kubernetes is managed under the hood in terms of control plane and etcd and service discovery and all that things. As a developer, I just want to describe to Kubernetes how I want my application to be run, and then it's Kubernetes' job to figure that all out. So what Docker image do I want to run? So we have hello world, and then how many instances of my application do I want to run? And how do I want deployments to occur? Is it like a very critical, business critical app where I want, like, let's say 2 instances running, and when version 2 comes along, maybe you want to gracefully drain 1 instance at a time and adding the version 2 while customers are still on the site so that they don't get affected. So these are some of the things we can tell Kubernetes to do for us. And what configuration file do we want? Do we want to load up some JSON files? Maybe we have some API tokens, some secrets that we have to configure, maybe some storage backends. So what configuration does our application need? And how much CPU and how much memory do you need? So you can tell Kubernetes, hey, if you see this node application go over 500 MB of RAM, restart it automatically. Or if it starts to eat a lot of CPU, Kubernetes can also throttle that application. And one of my most favorite features is automatically restarting the application when it becomes unhealthy. So this helps my fellow sysadmins don't have to wake up at night to take a phone call, because if a machine becomes unresponsive, Kubernetes will move that applications and all the applications that are on that machine to a machine that is healthy. So that's fundamentally one of the big purposes and things that Kubernetes solves. And then we also talk about how do we want our application to receive traffic. Do we need HTTP traffic? Is there a specific port that we're listening on? Do we need SSL? So we talk about desired state. So I'm going to show you guys what desired state looks like. Now, think about when you're scripting up a deployment, you write a lot of PowerShell or Bash scripts to say npm install and then run all these commands on the server. Maybe you're using Puppet, Chef, or some other configuration tools. Now, Kubernetes is very different. Whereas it looks at this desired state. We told Kubernetes how we want our application to run, and it will go and make sure the application is running in that state. So it's constantly monitoring the state of the world. And if a server dies, it will know this person wants 2 instances of the app running. Now there's only 1 instance, so let's get another instance up and running automatically. So that's called the desired state. The other thing is, if I had to have this talk 5 years or 6 years ago, it would be a very different talk. Because nowadays, a lot of us, if you have Docker installed on Windows or Mac, you probably have a Kubernetes cluster up and running already and you just don't know it. If you head over to the Docker settings, you can simply enable the tick box. And I'm seeing a lot of cool stuff happening in the Windows world, where they're also using like WSL backed engine. So you don't always need to run a hypervisor back end, but that's all coming soon. So at the moment, if you're running Docker for Windows, you actually have a Kubernetes cluster at your fingertips. So this is like really easy to get Kubernetes up and running these days, whereas in the past it used to be very difficult to get it up and running. And this is one of the things I always like advocate for as a developer. You want to run your application in a production-like environment. And if you have Kubernetes available at the click of a button, you'll see that it's very simple to get the application up and running, which I'm going to show you right now. And I also have a Kubernetes learning guide. So if you want to follow along anything that I'm about to show you, and you're having any questions about how to work with Kubernetes, even just if you're struggling with the command line, I take a very simple approach to this, where I go through the whole, getting Kubernetes up and running on Windows and Mac, how to configure kubectl, and then start interfacing with the cluster. So you can primarily just focus on the deployment side. So putting it all together. So what I'm going to do now is I'm going to head back to our terminal. And what we have in our terminal over here is a deployment. Now, I like my repos to look like this. This is how every Git repo should look. You keep everything very simple. You have a Docker file that describes your dependencies. You have your documentation right there, and you have a folder for deployment. So the ops engineers and DevOps can look at the deployment folder. They know exactly where to go. And developers can open up the source code, and they can see the monolith right there, but it's all hidden away, right? So it's very simple to navigate, and then a README file, of course. So to look at the deployment, we have this YAML file, deployment.yaml. Now again, I've kept this extremely simple, and I always like to keep this simple. So in Kubernetes, we say we have a deployment. I want to call it hello world, and I want to run 2 instances of my application. And then I also tell Kubernetes that, hey, I want to run 1 container, and I want to, this is the container image that we've just pushed to Docker Hub. And then I also say the port I want to run. Then I tell Kubernetes to monitor my application with a liveliness probe and automatically restart if it becomes unresponsive. And I also tell Kubernetes how much CPU and memory I'd like to use. So let's quickly go and deploy that, because we don't have much time. So what I do is I say kubectl get nodes. So you can see I'm running Docker for desktop. I've enabled Kubernetes, so I can just get going and focus on getting my app running. I don't have to worry about the low levels of Kubernetes. I say kubectl create namespace, and I create this namespace called example app, right? And then I take that name. So now we have a namespace, which is basically just like a project or a group of stuff we want to deploy. So we can group all these things together nicely. And then I can say kubectl, and I can specify the namespace. And what I do is I say apply, and I apply a file. So I can just apply deployment.yaml. So we go ahead and do that. Now what Kubernetes has done is it looks at this file, and this is my desired state, and it says, hey, this is what the developer wants. Let me make it happen. So I can say get pods, and now we can see we have 2 copies of our application running. So as a developer, I think this is really powerful, because whether you're running on Microsoft Azure or Google or Amazon, it doesn't really matter, because Kubernetes is completely portable. So for all that I know, these applications could be running on a cell phone somewhere, or they could be running, on any data center. It doesn't really matter. My focus as a developer is to get my code running in something that is like for like and as close to production as possible. So containers make that a possibility. And then the last thing I want to show you is how do we make the application public? So how do we expose that application? So for that, we have this thing called a service. So in a service, I can say, okay, I want a service called Hello World, and I want to select any deployments with the label Hello World. So that is our 2 applications that we're running. And I want to expose port 80, because a customer doesn't want to go to port 5000. So we're going to expose port 80, and we're going to map it to 5000. And the critical part here is we say type load balancer. And in the Kubernetes world, this is running on my Docker for desktop, so it's going to provision a virtual load balancer on localhost. If I'm running an Azure or AWS, it's gonna create the right load balancer for that cloud provider. So again, as a developer, I don't really care. I just want a load balancer, and I pretty much just do that. So I say kubectl apply my service, and Kubernetes will look at this as a desired state, and what it will do is it'll go and make that happen. So it's going to go to wherever it's running, issue a load balancer, and give me the address where I can access my app. And I can then follow that up by saying kubectl get service, and there we go. So I have an external IP called localhost. So what I can do is I can go to localhost, and this time we're getting our application from a container in Kubernetes. And the cool thing with this is I'm so much closer to a production environment. This is not like me stopping when I just have it working on my laptop. This is now running in a container in Kubernetes. So it gives me more confidence as a developer that this is something that, you know, the ops folks can actually be happy with, and they can run it very easily. So that is Kubernetes. Let's jump over. And that is the talk. So I've got quite a lot of links I can share. I can probably post them in the chat. I've just uploaded this slide onto SlideShare, so I'll post a link for that. I'll also post a link to a video that I've done. You can see it in the top right corner, which is basically similar to this talk, but it's just focusing on a little bit more details and in depth. So it's on YouTube as well. So if you want to follow that, the title there is as well, 0 lines of node to Kubernetes. And I can also share the links to the Kubernetes development guide as well. So yeah, thanks everyone for watching, and hope you guys got some value out of that.